Okay, so this one's interesting. It doesn't have a graph or a table. It just has some information. So I'm just going to dive right in. G prime. Okay, so maybe I'll draw a little sketch for myself. G and H. So there's two different equations. So G of H is 1. And H of 5 is 1. Okay, the line y equals, okay, that looks like it's a funny format. So let me change this to point slope form. Okay, so this is 5, 1, and slope is negative 5/3. And they're saying that's tangent to both the graph at that point. So this point right here, the slope is down 5, right 3, up 5, left 3. So this is the tangent line. Okay, so whatever the curves look like, I don't know, but I've got something where they both hit here. Okay, so the slope of both curves is negative 5/3 at that point. Okay, so the slope here is y prime at 5, which is negative 5/3. Same as slope of tangent line. So G prime of 5 is the same slope of the tangent line at x equals 5. Okay. B be the function given by that, find an expression for B prime. Okay, so B prime, I'd use the product rule, so 2x squared times G prime of x plus G of x times 4x. And then I want B prime of 5, so that's 2 times 5 squared times G prime of 5 plus G of 5 times 4 times 5. Okay, so that's 2 times 25. G prime of 5 was negative 5/3, plus G of 5 was 1, I believe, and then times 20. Yeah, so that's the answer you should leave. Okay, now I'm going to put the other answer later, but that's the answer you should put. This is the answer as long as an Algebra 2 student could type that into their calculator. That's a fine way to leave it on the AP Calculus exam. Okay, find an expression for W prime. Okay, so this would be quotient rule. I like to do the bottom of the quotient rule first so I don't forget to do the bottom. So it's denominator, low, d high, derivative of the high, I'm going to do that later, minus the high, okay, times the derivative of the low. Okay, it's just that the derivative of the top looked kind of complicated, so I was procrastinating that. So denominator times derivative of the numerator, low d high, so that's h prime of x minus 1, minus high, d low, over low. And it wants it at 5. Okay, so let me substitute 5 in. So then that would be W prime of 5 equals 2 times 5 plus 1, 3 times h prime of 5 minus 1, minus 3h of 5 minus 5 times 2 over 2 times 5 plus 1 squared. Okay, h prime of 5. So I guess I'm going to simplify that to 11 just because it's shorter because I don't have too much space. H prime of 5. Now it said H and F or G both have the same tangent line, so its slope is also negative 5/3. Minus 1 minus 3 times, it also said that H of 5 was 1. Minus 5 times 2 over 11 squared. And you should leave it like that. I will work it out later just so you could check if your answer is the right, but that's the way you should leave it. Okay, I'm going to put this later so I remember. I'm going to simplify. Let m equals the derivative. Okay, that derivative is Leibniz. So write an expression for m prime. Oh, I need m first, so let me start with m. The derivative of an integral is Leibniz, so you substitute in the top bound, multiply it by the derivative of the top bound, minus substitute in the bottom bound times the derivative of the bottom bound. So m of x is 2 times g of 2x. Okay, so m prime of x, which is what they want. 2 is a constant, so you can keep it. Take a derivative of the outside, keep the inside inside, times 2. And then substitute in 2.5. 2g prime of 2 times 2.5, which is 5, okay? That's the only thing we kind of know in this problem. 2g prime of 5 times another 2. That's that slope again, negative 5/3 times 2. Let me check. Is the slope right? Yeah. Okay, just check. Negative 5/3, and then this is your answer that you would leave. And then we'll work that out later. But don't work that out later on the IAP test. Just leave it like that. Okay, it is known, so this is the same problem, that C equals satisfies the conclusion of the mean value theorem applied to M on the interval. Use M prime of 2 to find this. Okay. Okay, so that's odd. So let's see. It says it's known that 2.5 satisfies the conclusion of the mean value theorem applied to M. Okay, so that's going to be algebra slope would be M of B minus M of A over B minus A equals M prime of C. That's mean value theorem. So that would be M of 4 minus M of 1 over 4 minus 1 equals M prime of 2.5, because they said that. Okay, what is M of 4? Okay, so I'll write this over here. M of 4, well, let me write M of x in this section so they could see it. So M of x is 2g of 2x. So that means that M of 4 and M of 1. Okay, M of 4 is 2g of 2 times 4, 2g of 2 times 1. So that's 2g of 8, and this is 2g of 2. Okay, so that means this becomes 2g of 8 from here minus 2g of 2 divided by 3 equals M prime of 2.5. Satisfies the conclusion of the mean value theorem. Okay, so this would be multiply by 3, divide by 2, and g of 8 minus g of 2 would be 3 times M prime of 2.5 divided by 2. My question is that what they wanted? They probably actually want M prime of 2.5. Oh, I found M prime of 2.5 in step D. So let me draw this up here. So that's g of 8 minus g of 2 is 3 times that answer I just got in part D, which is negative 20/3. Over 2. We'll put the over 2 here. So that would be negative 10 is g of 8 minus g of 2. Huh? Cool problem. I know you guys probably don't think they're cool, but try to do them with a smile. Think you know more than other people at other schools. So throw your math at it. Your teachers have taught you well. The main thing is try not to be nervous. Just do what you can and figure we're better than other schools. We get half the people usually at Walnut get 5s. So you guys are prepared. So don't worry. You're prepared, regardless of what work you've been doing during the closure. Okay? So you need confidence. Just go in with a smile. Go in with a positive attitude. Okay? And try to have fun with the questions. Okay? Okay, so the function g satisfies that for known. It's known the limit can be evaluated using L'Hopital's rule. So that means that it must be 0 over 0. So use the limit to find f of 5 and f prime of 5. Show the work that leads to your answer. Okay. So I'm going to make this bigger if I can so that I can write smaller. Okay, so limit of g of x. Okay, now it says I know I can use L'Hopital. So, but the only way I can use L'Hopital is if when I substitute it in, I get 0 over 0. So maybe that fact is going to help me find those values. We've never done a question like this before. These are unique. So just throw your math at it. Okay, so substitute in the 5. 5 times the cosine of 1/5 times pi times 5. That's cosine of, okay, over 3 minus square root of f of 5. Now the numerator is 5 minus 5. The denominator is 3 minus integral of f of 5. Now it told us that we can use L'Hopital. So if we can use L'Hopital, then this value right here must be 0 to use L'Hopital. Some people put an S in it for the hospital, and then some people put like a little caret over that. So either way is fine. Okay, so what that means is therefore 3 minus radical f of 5 has to equal 0, which means that would be what? Move the 3 to the other side. So that'd be, let's move the f of 5 to the other side. So that's 3 equals radical f of 5. And then we're going to square both sides. Now you can only use blue or black ink on your test, so you can't use all my colors, these crazy colors I've been using, but hopefully this has made it easier for you to see. Cool, I just found out what f of 5 had to be. Okay, now it says the limit can be evaluated. Use that to find f prime of 5. Okay, well, let's substitute and see what happens. I have no idea what's going to happen. Okay, so this is use L'Hopital. So L'Hopital, I have no prediction here, so it's kind of interesting. I don't know how they're going to find me f prime of 5. So x is 5, so that's 1 plus 5 times negative sine, I'm taking the derivative, 1/5 pi. L'Hopital, remember, is the derivative of the top and then the derivative of the bottom. Okay, over 0 minus 1/2 f of x to the negative 1/2 times f prime of x. Okay, I don't see how I'm going to fit this in, and I don't even know what's going to happen. Okay, so this cancels. Okay, so this is 1 minus, if I substitute in a 5, that's 0. So sine of pi is 0. So that's 1 minus 0 divided by, okay, negative 1/2. 1 over f of x, so that's f of 5 to the 1/2 square root times f prime of 5. Okay, so 1 over negative 1/2, f of 5 was 9. Oops, that's in the denominator. So 1 over 9 square root times this f prime of x, or f prime of 5 that I don't know. And this is 1 over negative 1/2 times 1/3, and the f prime of 5 is here. So if I flip that, that's negative 6 over f prime of 5. Well, how about the continuity rule? The continuity rule says that the limit has to be the function value. So that must be g of 5, right? Because the limit has to be the function value. So remember, I'll write it here. The rule number 1 was g of 5 exists. This is the 3-part test for continuity. Does it say it's continuous? Probably. G satisfied. Is g continuous? Yeah, they're called differentiable functions, so that means it's continuous. And then second, remember you do the limit as x approaches 5 of g of x. And then rule 3, or the third part, says that rule 1 equals rule 2. So that's why I'm saying it has to equal g of 5, because the limit has to equal g of 5. Okay, and then g of 5, according to the picture, was 1. Ha! Dang! Crazy question. Okay, so I'm going to go up. So this is 1 equals negative 6 over f prime of 5. Cross multiply, f prime of 5 equals negative 6. So I just found f prime of negative 5 just by driving. I call it driving in HL. basically what I'm doing is I have no idea what to do, and I'm just trying to figure out everything I possibly can about the question. Okay, so that's interesting. That looks like squeeze theorem. Oh, shoot, I think I might need to do a video on squeeze theorem. Okay, so this one looks like squeeze theorem, which you guys don't really know. So squeeze theorem is not one that you really have dealt with very much. Okay. It is known that h of x is less than or equal to g of x. So h is the lower one. So this is the h. This is the g. So my h is lower than my g. Okay. This is squeeze theorem, but you guys don't know squeeze theorem. K is between them. Okay, so I'm going to do this in a color. So this is your lesson on squeeze theorem. It's very cool. So let me not use red because I was using red for corrections. So let me use light blue. So the idea is this K, which is blue, is between, and let me highlight these. We're going to have G be dark blue, and we're going to have H be red. Okay, so H is red. H is right here. And remember, they're connected right there. And then dark blue is G, so that's this. Now K is between them. So K is light blue. So where in the world am I going to put K? It's going to have to squeeze in here. Oops. So it's going to have to squeeze in there. So this must be K. So this is called the squeeze theorem, actually. And the limits have to match at that point. Let me show you the picture again. So K is squeezed in between there. So they have to share that limit being 1 or the y value being 1. So that's called the squeeze theorem. Okay, so let this be a function that, for this, is it continuous at 5? So I would say yes, because it has to squeeze in there. Now, is it possible, does it say anything about K? Does K have to be... Okay, is K continuous? Well, I'm looking at these two. These are continuous because they're differentiable. So the y value of the dark blue one is equal to the limit. And the y value of the red one is equal to the limit. So my question is, definitely the limit is true because that's the squeeze theorem. But could I put this blue dot right here somewhere else? I can't put it there because it would be above G. And it says that K is always between G and H. So I'm going to go with yes. But it says justify your answer. So I'm going to put since K is between G and H, equal, and the limit as x approaches 5 of h of x equals 1, and limit as x approaches 5 of g of x equals 1, then by squeeze theorem, the limit as x approaches, the limit as x, that's hard to see, but x approaches 5. Let me put that up a little so you guys can see it better. So my app doesn't like that part right there. Okay, so let me write it higher. So the limit as x approaches 5 of k of x, which is squeezed between, is also 1. G of 5 equals h of 5 equals 1, and k is between. So I would say k of 5 equals 1 also. So I would say that means that k of 5 equals the limit as x approaches 5 of k of x. So I would say it is continuous. So I would say k is continuous because that. Dang, I don't know how anyone could get those points. You guys, G is really tricky. You don't have to get 100 to get a 5, okay? You don't have to get 100 to get a 5, so don't panic. We just, it's going to be on a big old curve, so who knows how they'll score it. But we just have to be better than students at other schools, and you guys are better, okay? So you're going to be fine. Okay, that's 25 minutes. Is there another page? Yes, but that is for sample question 2. So you could go back and check your answers. But I mean, I'm fast because, you know, I'm a teacher, so I'm fast. So that squeeze theorem is a little interesting. But the idea of squeeze theorem is perfectly this picture. You basically have a situation where you have a middle function and you have the top function and the lower function both at that same spot. Let me see, is H continuous? Yeah, H is continuous. Okay, so I keep trying to think maybe I could have that red circle. You know, I'm thinking that I could just move this red one away, like say it's down here, but it's not because they told us that H of 5 was 0. I mean, H of 5 was 1, so. So the blue is squeezing between the dark blue and the red. Okay, so that's kind of cool. Oh, let me fix these. 50, 70. Oh, no, that's 50, negative 150. Let me figure this out so we can check the answers. Negative 150 over 3. Right, so that'd be 10. No, 250. That's negative 250 over 3, isn't it? 10. 250, and this would be, what, 60 over 3? So I think this is negative 190 over 3. 3 doesn't go into the 190. Okay, so, and then this one is what, negative 5? Is that a minus 1? That's a minus 1. So that's negative 5, negative 6. So negative 66. I'll probably just type this one into the calculator. Negative 2. So that's negative 4 plus plus. Negative 62 over 121. I don't guarantee these answers right now. Okay. Remember, the answers you're supposed to give anyway are these answers. This one is the answer you want to give. This is the answer you want to give. This one is this answer. Give this answer. Don't simplify it. I only simplified it because I needed to for the other one. This is negative 10. Technically, I probably shouldn't have simplified that one. This one is the F. This one's the F prime. And this one is, it's continuous because, but you'd have to write the whole thing out anyway. So I'm at 22 minutes. I would go back and double check things and not turn it in early. I think 5 minutes is sufficient to turn it in. So, but you'll probably still be working. And if you don't finish all of them, don't panic. Submitting A through F or A through E and then G or whichever ones you want to do is much better than not having it submitted at all. So don't try to eat into your submission time to finish one last part. Just give yourself 5 minutes, because if you don't submit it, then that would be where the problems come in. Okay, so I'm going to do the other one. So let me go to the second page, and then I'm going to write down my time. 15 minutes, so this is 8:15 p.m. Let me go back to pen and erase that. Okay, so let me go back to pen, but I don't want yellow. We'll do blue. So this is also AB. This is 8:16. Still good for BC though. Okay, let me go back to my question. Nope, it wasn't that one. My question was on my write on PDF. So where is it? Is it that one? Oh, I think it's this one. Okay. So, okay, I have a table and I have a graph. Okay, table and a graph. Graph of H, okay, which is not mentioned in the table. Let F be defined by this. Okay, I know lens, I know sines. Maybe you have your formula sheet where you can look stuff up. Twice differentiable function, so all the theorems work. The table above gives values of G and its derivative, G prime at selected values. Okay, let H be the function of the graph. So this is H. We already have that H. 5 line segments shown. Okay, so I have an F, I have a G, and I have an H. Find the slope of the line tangent to the graph at F. Okay, so I need F prime of X, and then I need F prime of 1. So F prime of X, and you could use a calculator for this. Cosine of this times derivative of the inside, plus 1 over 2 minus x times negative 1. Okay, or you could use n derived, so I'll show you that after. So this would be pi times 1 times pi plus 1 over 2 minus 1 times negative 1. And remember, this is the answer you want to give them. There's no reason to simplify. If an Algebra 2 student could type it in, then it's sufficient. Okay, or, I'm going to put or. This is a calculator way. Okay, so in the calculator, let me actually, in this video, I'm going to go to the calculator on my screen. Oh, let me take a picture of this so I can see. So this would be, I don't actually take the derivative, and I let the calculator take the derivative for me. And I want it at what, 1? Okay, so let me show you. Where is my Wabbit Emu? Here is my graphing calculator. Let me turn that around to show you. So what I would do is I would type y equals in. Okay, and they let you use a calculator. They say calculator neutral, so they're saying that it's not going to hurt you or help you if you have a calculator. Okay, so this is, so if you don't like the calculator way to take the derivatives, the way we already did is fine. So this is ln of 2 minus x. Okay, and then what I like to do is, it's math 8, that's n derive. Okay, so it looks like that, ddx of y1, so you hit the variables button, VARS, go to y variables, y1, okay, and I want it at x equals 1. Okay, so I'm going to take a picture of that, and I'm going to compare it with my other one. Okay, let me go back to my other app. Where was I? Right here. Let me turn it for you. And the calculator, I would write ddx of f of x at x equals 1. I would put on calculator is approximately, and then let me write down what I got. I got negative 4.142. I like to round, but AP says that if you want, you can just cut off the rest of the digits. So this answer would be okay also. Oh, hold on. Sorry, that's not it. I forgot some digits here. So negative 4.141 would also be okay. And then I'm just curious. So now that I have my calculator over here, I'm going to type in that f prime over there and see if it's right. So let's see. Let me type it into my phone calculator. Cosine pi. Oops, somehow I got E. Cosine pi times pi minus 1. No way, I got the same answer. Okay, good. So we're good. That's the answer. Okay, let k be the function k. Oh, that's kind of cool. Okay, so this is k. I'll make it bigger so we can write smaller. K prime of x is derivative of the outside with the inside still inside times the derivative of the inside, which is f prime of x plus 0. Make sure you find the derivative with the x before you substitute in the number. H prime of f of 1 plus 2 times f prime of 1 plus 0, so that's it. I need f of 1 and f prime of 1. Oh, those were my signs, though. Oh, that's annoying. And then h prime of that. Okay, so this is, I guess I'm going to write my f equation down here because I can't see it very well. Oh, I'll just zoom out. Okay, there we go. So never mind. So this is h prime of, okay, let me just find f of 1 over here. F of 1 is sine pi plus ln of 2 minus 1. Okay, so you could type that into the calculator, and it's 0 plus 0, which is 0. So this is 0 plus 2. And then the derivative, oh, which we just found out. I wouldn't put in that rounded answer, though. So I feel like I would put in the cosine of pi times pi plus, that's 1, that's minus 1. I feel like I would put that in. I really wouldn't want to put the rounded value. If I did put the rounded value, I guess I would put h prime of 2, and then I would put cosine, well, let me show you the other way. I would do h prime of 0 plus 2, and then over here I would put negative 4.141 ... And then I would store that value. So I think that would be acceptable also, but you really would need the ... to show that you didn't round early. So depending on what way you did it, it's okay. H prime of 2 times cosine pi times pi minus 1. Okay, h prime of 2. What was h? H prime of 2. 2. It's a line. So the slope here would be down 1, right 3, because it is a line. And lines have slopes the same all the way. So that's down 1, right 3. Okay, so that's negative 1/3. So this would be negative 1/3 pi cosine pi. I know cosine pi is negative 1, but I don't need to simplify that for BC. Or if I did it this way, that would be h prime of 2 times negative 4.141 dot dot dot, which is still on my calculator. And then that would be negative 1/3 times negative 4.141 dot dot dot. And then I feel like they would take this answer. But I might type it in more. Okay, so this one, let's see this one. This one, the antiderivative of, I'm going to zoom in so I can have more room to write here in this little tiny space. This would be, the antiderivative would be g of x from negative 5 to negative 1. That's g of negative 5 minus g of negative 1. G was my table. Nice. G of, what was it? Negative 1 and negative 5. So g of negative 1 and g of negative 5. So 1 minus 10. Let me zoom out to check if that's correct. G of 1 is 1, and G of negative 5 is 10. Oh, that's a nice one. Oh, I love C. Negative 9. But we don't know how many points each thing is worth. Okay, so C was beautiful. B was a little weird. Oh, that's an infinite Riemann sum. Okay, I'm going to go to E. Infinite Riemann sums, most people always miss, so I mean, maybe we get it right, but let's wait on that one. What is the fewest number of horizontal tangents G could have? Okay, so horizontal tangents means G prime equals 0, and they want the fewest number from negative 5 to 0. G was the table. Okay, so I am going to draw G. So I'm going to do E above. So I'm going to put the problem is done above. So I'm going to do it up near the table. Okay, so from negative 5 to 0 is the whole way. Okay, and let me make some space over here so I could write. So I'm going to sketch it. So I feel like this is like mean value theorem, Rolle's theorem, something like that. So let's see, they're all positive y values. Oops. But a negative x value. So let's go over here. So negative 5, negative 4, negative 3, negative 2, negative 1. I feel like intermediate value, Rolle's theorem, mean value theorem, they're in that category, and I like to graph those. Okay, so 10, 5, 2, and then 3. I'm changing colors. So this next one is 3. So that went up. So here it doesn't have to have, I could have a wiggly. I could have gone up and then down, but not necessarily. So it says the fewest number. So I'm thinking this spot has nothing that has to be. And this is a graph of G. Okay, and then at 3, okay, I have that. And then at negative 1, what is it? Negative 1, it's 3. Oh, I just did negative 2. Negative 1, it's 1, so it's going down again. Down again below 2. So let me erase that little spot. Negative 1 below. And then 0. Now, it didn't say the endpoint. So 0 doesn't count. So at this moment, I would say that this one slope is down. This one slope is up. You had to hit 0 somewhere in there. So there's 1 right there. I had to hit 0 somewhere in here. I don't know where. And then I have to also hit it again because I was going up and then I went down and they're continuous. So I'm going to have to hit 0 there again, somewhere between negative 1 and 2. So I've got 2. I've got 1 between this section. And then I have another separate one. It could be the same one. No, but I think I have to have a minimum and a maximum. I gotta have a minimum and a maximum there. It goes down, then it goes back up, then it goes back down. I gotta have 2. So I think the answer is 2. 2. Justify your answer. How am I going to justify my answer here? I would put, I'm sure there's a theorem. So I also want to do the G primes because the G prime would be intermediate value theorem. So I think the G prime might be easier actually. Let's do the G prime. Okay, so this is going to be G prime over here. Okay, so this is G prime, and we'll see if I get the same section. So G prime is -5, -3, and then at -4, it's -1, and then at -3, it has to be 4. Okay, so intermediate value theorem says that if one's below and one's above, and this is right in the middle, anywhere in the middle, but specifically 0 is often done, it has to hit somewhere in between there. So that's a little easier justification for me. So that's -4. So it has to hit in between -3 and -4. Okay. And then the slope, the next slope for G prime is 1. Okay, so that's at -2. And then the slope is -2. So the slope has to be below again. So I've got to hit again. So I have to hit again between -2 and -1. One's above, one's below. I like intermediate value theorem for an explanation. And then the next one is down -2. So I'm going to do intermediate value theorem on this one. So I'm going to look at, instead of the G's, I'm going to describe it with the G primes. So I'm going to say G is continuous, because that's what G prime is continuous. That's what allows me, we'll put since G is differentiable, then G prime is continuous. On the interval from -4 to -3, and what was the other one? This spot, -2 to -1, and then I would say G of -4 is less than 0, less than G of -3. Okay, because 0 is between, right? 0 is between, oh, now that's G prime, not G. Those are G primes. So G prime of -4, which is -1, is less than 0. So 0 is in between. And then there's 4. So 0 is in between these two. So, so by intermediate value theorem, which I would write out, there exists a C such that G prime of C equals 0. Was I trying to prove G prime? Yeah, horizontal tangent, so I wanted a 0. So G prime of C equals 0, where C is between, so C is between -4 and -3. Same thing with -2 to -1. So this instead, though, the G prime of -1, that's a prime. Let me write this over here. So G prime of -1 is less than 0, less than G prime of -2. So again, 0 is in between here. So 0 is in between those. So there exists a C between -1 and -2 such that G prime of C equals 0 by intermediate value theorem on G prime. So by intermediate value on G prime. Okay, so that's the reason. Which one's that one? That one's E. So this is E. So the answer is 2. And then that's my explanation. Dang, that's crazy. Okay, so what about infinite Riemann sums? So infinite Riemann sums, the idea is often this outside is your delta x. Okay, so if you were thinking of a number line, I started at some value. Now it says a lower bound of -1, so that's good. And then I feel like all of these would be 5 over n, 5 over n, 5 over n. Okay, so this value right here would be -1 plus 5 over n. The next one would be -1 plus 10 over n. -1 plus 15 over n. And the last one, I don't know what it would be, but if you have n 5 over n's, that would be 5. So that would be negative 1 plus 5 would equal the right endpoint, which is b. So that should be 4. So that should be 4. Evaluate the definite integral. Okay, so let's check. So this is h of, this number right here. And then h of this number, because I have to plug in k equals 1, would be negative 1 plus 5 over n. And then that would be h of this times the width of each one. And then I would be so it looks like this is a right endpoint Riemann sum. Okay, so this would be the integral from, look at my number line, from negative 1 to 4, because the whole width is 5. And it would be h of x, because those are my different x values I'm substituting in. Now I don't include, the delta x is the dx, so that 5 over n I don't put in. And the 5 over n is in here, so that is delta x. Okay, and then I want the integral from negative 1 to 4. So this is h from negative 1 to 4. 4 is over here. Okay, this is above the x-axis, and this one is below the x-axis. So those cancel. That's a half, right? The slope is up 2, right 1. Okay, so those cancel, so that's 0. This is a triangle, 3 wide, 1 low. So that would be 1/2 times 3 times 1, but negative because it's below. And this would be 1/2 times 1 times 1, 1, 1. That's above, so that would be positive. So that would be the answer. But let me write that down here. Let me zoom out and see if I could write it still. Okay, so this would be 1/2, 1 times 1, right? And then it would be minus, because that's negative, a negative region. That would be 1/2, 3 times 1. I don't want to put 2 negatives. I want the region to be negative because that y value is kind of a half. And then I would put plus 0 because that part was 0. And then that's technically the answer, so you would want to leave it like this. But that's 1/2 minus 3/2, which is negative 2/2, which is negative 1, if you just want to check your answer. Okay, so above is my work near the table on that one. How'd we do for time? 35, 8:35. I'm way over. I'm 19. So that's interesting. So don't worry. Remember, if you don't finish, I mean, I finished barely in the time, and I did, a little bit differently, but pretty much I went over. So, I mean, if I can't even get it done in time, then how are you expected to do it in time? You're not. You're just, maybe they wanted to know, do you know the intermediate value theorem, or do you know infinite Riemann sums? And they don't really care if you know D or E, D and E. And even then, if you didn't know D and E, and you got all the rest right, and you did okay on the other one, I still think that you could get a 5. You know, and at least you would definitely pass. You don't have to know both D and E and be an expert to get a 5. So probably maybe 1, get some points, maybe. Anyway, interesting questions, and maybe not. Remember, you have to be better than the next guy. Okay, but we got A, B, C right. They did say that you're not expected to be able to finish all the ones in the time period. Anyway, so that's the end. And that's it. Good luck. Okay, we'll see. Hopefully I didn't miss any of these. I probably did, though. I'll look at the answers, and I'll add the videos at the end if I did miss any.